Have you ever wondered how a space shuttle moves when there is no atmosphere in outer space? Well, today we are going to explain the science behind a spacecraft moving in a vacuum of space. Hey folks, welcome to Concepts Explained. So first off, let's clear up a common misconception. When we talk about lift, we usually think about airplanes gliding through the atmosphere, right? Airplanes rely on the air pressure differences created by their wings. But in space, there's no air, so how does the space shuttle maneuver? So to understand this, you need to understand Newton's third law of motion. Newton's third law states that for every action, there is an equal and opposite reaction. This means that when an object exerts a force on another object, the second object exerts a force of equal magnitude, but in the opposite direction to the first object. Sounds pretty straightforward, right? But how does this apply to something as complex as a space shuttle engine? Let's take a closer look at the space shuttle. The shuttle's main engines burn liquid hydrogen and liquid oxygen, creating a massive amount of hot gas. When these gases are expelled downward, they push the shuttle upward. This is a perfect example of Newton's third law in action, as the force exerted by the gases escaping the engine pushes against the shuttle, propelling it into space. Pretty cool, right? During launch, the engines produce around 1.5 million pounds of thrust. That's like having 100 elephants pushing upwards. But it's not just about the thrust. It's also about overcoming the gravitational pull of the Earth. The shuttle has to generate enough upward force to lift off the ground and continue its journey into orbit. That's why it's very crucial for every engine to perform ideally, or else the rocket cannot put enough thrust to lift the shuttle and it fails. Okay, what if an astronaut forgot to pack his bag of potato chips? How would he make a U-turn? In order to steer the space shuttle, we need RCS. The reaction control system is like the steering wheel of the spacecraft. A reaction control system consists of small thrusters placed in different locations on the space shuttle. In simple words, if we want to make a right turn, the left side thrusters will be activated. RCS thrusters work on the principle of Newton's third law of motion. They are used to provide small thrusts which can help the space shuttle to control the orientation of the spacecraft and move in different directions. They play a very crucial role in the docking of the space shuttle with the International Space Station. So that's how our space shuttle moves into space, even with no atmosphere. If you like this video, please give us a thumbs up and share this video to your friends and family, and subscribe to the Concepts Explained channel for more science videos. You can ask about your queries and we might make a video on it. Just comment your queries below. Concepts Explained by Thinking How.